Chapter 2 is about operating system structures. So here mainly we will learn about different operating system services and how an operating system allows these services to obtain by application programs, and what is a system call, and different operating system designs based on different requirements. So these are the topics that we will be covering in this chapter. So as I explained, initially we will see the different services and what is a system call, how a system call operates, and what are the different system calls available for different services, and what are system programs, different operating system design and how they are implemented, and what is a virtual machine and the importance of it, and different ways of debugging an operating system, and how a system starts using an operating system. So these are the objectives in the course in this particular chapter. So an operating system provides various different types of services. So one of the important services that it provides is the way to communicate for users using a user interface. So mainly there are two different types of user interfaces available in operating systems. Those are command line interface and graphical user interface. So we call it as CLI and GUI. So all the available operating systems has a graphical user interface, but it can be different, but they offer a good graphical user interface for the convenience for the users to install applications, use applications, and can run multiple applications without any difficulty. And another important service is program execution. So a user will be able to install different applications, so they can run multiple programs. So when we run multiple programs, it has to be properly managed, what programs to be executed and how they are executed, if there are any errors, how to handle the errors. So those are parts of program execution. Another service is input-output operations. There are a lot of devices, input-output devices, which are connected for the computer system. So all these are managed by the operating system. So how these devices are managed, how the devices are being used, so those are services provided by the operating system in IO operations. Then file system manipulation. So we can create files, we can create folders, different programs will access the files, access the folders, do certain modifications, we can delete files. So all this has to be properly managed. So file systems are also part of operating systems. So different operating systems will give these services differently. So we will see some examples later on. So the services of operating system can be visualized like this. So on top of the services we have user applications. So users can use the available application programs in an operating system using the command line, or if there are any batch system available, or graphical user interface. So user interfaces are also a part of a operating system service. Then the user interfaces will communicate with the hardware through the available set of system calls. So any particular user application that wants to access hardware by using the available services in the operating system, it has to go through a system call. So in chapter 1 also we have discussed about system calls and interrupts. So here we will mainly see how a system call works and how it uses different services in the operating system to handle the hardware functionality. So any service provided by the operating system will be handled through the necessary system calls. So for each particular service there will be a separate set of system calls available which can be accessed. So when we go more into the services, communication is another service. That means programs, applications or processors can share information. So those has to be managed properly inside the operating system. So communication is vital for an operating system because it has different levels of communication. Inter-process communication, inter-application or inter-program communication will be also considered. Then error detection. So operating systems may go through a number of different types of errors. For example, application level errors, when an application fails to execute, or process level errors, hardware errors. So like this, there can be different levels of errors that has to be handled by a operating system. So if a part of a particular device is not working, how to use the available resources, and when an error occurs, what would be the appropriate action to be taken, and what are the debugging facilities. So like this, another important service is error detection. So operating system will provide various other functions inside to support the services. One is resource allocation. That means there can be a user which runs multiple applications. So like that, there can be many users who run multiple applications at the same time. So based on that, we have to maintain the different users, their data, as well as the executed applications or programs. So accounting is important to maintain different users with their credentials. They have to separate the private data they have and use the common programs. So sometimes certain applications and application execution will be given to a particular set of users. So accounting is another important functionality. And the other important functionality is protection. So protection and security feature is very important because there can be internal threats inside particular computer system as well as external threats. That those threats coming from outside with the form of different types of viruses. So protection is important. We have to make sure certain access restrictions for certain users. Sometimes we can give read permission only, sometimes read and write, sometimes we can give permission to read, write and execute. So like that, protection will vary based on different access level. Security we need to consider when there are internal and external threats to a computer system. So operating system should be always equipped with protection and security to maintain the integrity of the available computer system, and also it has to isolate the user's private data, and also same time a user should be given certain common applications to access, execute and do their necessary work. The command line interface is very important for operating systems, mainly when it comes to quick execution of programs. Some can be critical programs, and efficiency is high in command line interface because it uses very small amount of resources to run the command interpreter, and operating systems like Linux or Unix, they have a very powerful command line interface where users enables to use quick execution of programs. So mainly when it comes to running servers, server operating systems, they tend to use the command line interface because using the command line, the execution of programs can be quicker, quick response, and lower utilization of resources because it's lightweight, and it provides a lot of facilities for execution of commands for the users. So we will do certain examples using command line interface, and I will show you how an operating system can be installed using the command line interface by running certain necessary commands. But the popular interface type is graphical user interface. We call it as the desktop in Windows. Linux will also have different types of graphical user interfaces. So the advantage of the graphical user interface is convenience and user friendliness, because we can easily identify the application it's visually available, so we can run and execute multiple applications very easily. So all the devices are also dynamically linked to the user interface. We can use mouse, keyboard, we can see the mouse movement real time. So that is how the graphical user interface works in many operating systems. So different operating systems gives different graphical user interfaces. In Windows we have a desktop as the graphical user interface. In Linux we have various different types of graphical user interfaces. So we'll see later on the different types of graphical user interfaces provided by Linux. So they use GNOME, X Windows, and also there are some attractive graphical user interfaces where you can use as 3D interfaces. So this is an example of a command line interface where you can run only the commands. So it uses very low resources, but it can run all the necessary commands. So because of the lightweight service provided through CLI, we can run the available commands quickly. So this is an example of a graphical user interface in macOS. So like this, you can experience many other operating systems like Linux, Unix, Solaris, and Android is also an operating system. So you can see the different types of graphical user interfaces provided by different operating systems. So now we'll see what is a system call. So system calls are provided by the operating system. So whatever the application that we use for the user's end or in the user level needs certain execution to do certain tasks. For example, when we open a Word document, opening itself is a task. So when we double click on a particular document, the application will call for a system call relevant for that particular task, that is opening a file. So what happens is, to execute the system call, the operating system should be in the privilege mode. Remember, in chapter 1 we discussed about dual mode operation. So if the operating system is in non-privileged mode, then it's in the user mode. So but to execute a system call, the operating system should be on the kernel mode. So if we want to open a file, we double click the file, then the application program will start to execute the system call relevant for that particular task. So then the mode is changed to the kernel level, then the system call will be executed and it checks whether it is available on the main memory. If it is available, it will start execution. So on the screen we will see the Word document opening up. So how do these system calls are available for the application programs? Through API, application program interface. So all the applications that is available in the computer system will be using the available devices through the relevant system calls. So different operating systems will provide different APIs for application execution. So in Windows we have Win32, in Unix, Linux we have POSIX API. So like that, there are many different types of application program interfaces provided by different operating systems. So why do we use the API rather than the system calls for the communication? Because API will give you certain functionalities where you can use the necessary services through the system calls. So even when the system is upgraded or the operating system is upgraded, the applications will connect to the API. From the API it connects to the system call, then it goes to the hardware. So the advantage is, when the operating system is upgraded, system calls can be also modified by it, but the application are using the API. So the application does not directly connect to the system call, it connects to the API. API will identify what are the necessary system calls that is required for certain tasks. So this is an example of a system call for copying the content of a file to another file. So what we do is we need to copy the information from one file to another file. So there's a existing file and a destination file. So that is indicated here. So how does this sequence of instructions happen? First, the system should identify the source file. So it will check whether the source file is available. If available, then it takes the source file, saying that the source file is available. Then if the file does not exist, then you have to display to the screen file does not exist. So you abort that task. Else we create the file and then we'll start copying the content from the source file to the destination file. So it will run in a loop until there's no information to be read on the source file. So you can see in the loop one instruction to read the contents from the source file and the other one is to write the contents to the destination file until read fails. So that means until the content is empty on the source file. So when the writing is completed, there will be a message on the screen, the copying is done, then it aborts. So that is how this particular mechanism inside the operating system works using system calls. So the API provides different ways for the application programs to use the system calls. So this is one particular example of a system call, right? So you can see there are certain parameters we need to consider. Right? So this is just an example for you to understand the nature of the API, right? So each API will provide the necessary detail for the application programs. So the application programs will call the necessary system calls to the API. So system calls are available differently for different services. For an example, to read a file, the system call is available as read. To write a file, the system call write is available. So like this, to create a directory, to delete a file, so save it to the hard disk, take a printout. So like this, there will be different system calls relevant for different tasks. So all are named and available through the API. So whenever we want certain tasks to be done through the application, we'll always refer to the API, load the relevant system call and do the task. So the operating systems always provides the API as I mentioned earlier. So the system calls are not directly visible for the end users. So they will see only the API. Through the API, they will execute the necessary and available system calls inside the operating system. So this is another example. So the user application wants to open a file. So as I explained earlier, so we want to open a Word document. So what happens is user application will send the task to open a file. So the end user can click on the file. So then the application will start execution. It will try to open the document to us. So through the API, it will call a system call called open and start opening the file. So again, it will check whether the the file can be opened successfully. If it is possible, then it will start opening or executing that particular set of commands to open the file. So to execute a system call, the operating system should be on the privilege mode. That means it should be on the kernel mode. So the system call will run only when the operating system is in the kernel mode. So the mode of the operating system will change to the kernel mode. Then it will start the execution, that is to open the file. So when the file is opened, then it will be available for the user, and it returns that the task was successful and user can move forward with the application. So different APIs provide different system calls. So this is a simple C program. You can see it includes standard input output library. So that means to print it requires standard input output. So in this program that you will see, it has to print. So what happens is to execute the print operation, then the operating system call should be executed. To do that, it uses the available library and identify what is the required system call. So you can see to print, the system call is write. So it will start executing the write when the mode bit is changed to the kernel mode. So it writes the particular message to the screen, and then it turns back to the user mode. So that is how this system calls communicates through the API to the end user. So for system calls, there are many parameters that we need to consider. So from one system call to another system call, the number of parameters will be different. So based on that, the parameters should be passed for the system call to function properly. So in operating systems, there are three different methods of parameter passing. So the simplest method is the operating system will pass the parameters to the register. So that is the easiest way of doing it. Then from the registers, the parameters will be available for the system call. The second method is the parameters are stored in a block in the memory, a small segment in the memory, and the address of that block is passed to a register. So register knows, the CPU will identify where the parameters are. So the system call can take the parameters from them. So Linux and Solaris versions are using the block method. The third method is called as a stack method. So a stack is actually a preliminary data structure. So you will be studying this in the data structures and algorithms. So very important data structure, a stack where you can push the parameters inside and you can take the parameters outside. We call it as pop. So using push and pop methods, we can save and retrieve the available parameters for a system call. So the disadvantage in using registers memory size is very limited. So the other two methods, block and stack method, does not have any limit for parameters because it can handle in many number of parameters than the registers. So this is how the parameters are passed in the block method. So you can see the registers will read the necessary parameter details inside the memory by reading the address available in the memory block. So then the system call can use this to its execution. So system calls are different for different services. So there are many system calls for each particular task. For each service there will be a separate system call. So each system call will have its own instructions as well as the number of parameters. So we will see some of these system calls. So you can see for different services like process control, file manipulation, information maintenance, protection, there are different system calls for each task. So the other thing you need to remember is from operating system to operating system, system calls are also different. So that is how the system calls are implemented inside the operating system. So this is an example of MS-DOS, which is not very much used today. So this is a single tasking operating system. So at any given time a single program will be running in this operating system. So you can see at the startup there will be the command interpreter. So in MS-DOS there is no graphical user interface, you will be having only the command interpreter, and at the startup only the command interpreter will be loaded to the memory. After that you can run a single process at any given time. So you can see the structure of the main memory. So it's simple. When you have operating system like the single task, that means only a single process will run at any given time. So memory management will be easy. We have to consider only a single process at a given time. So this is an example of an operating system where it can run multiple processes. So we call it as multitasking, right? So it can run many applications. So each application will have many processes. So all will be loaded to the main memory. So memory management is in this type of operating system is complex because at a given time there will be multiple applications running. So there will be several processes that needs to be executed to facilitate the user. So free memory management, uh, process management, inter-process communication, device management. So all this will be handled by the operating system. So each will be considered as a service provided by the operating system. So each of these services will have separate system calls as well. So system programs are the services provided by the operating system for the end user. For an example, file manipulation. So we can create a file, we can create a folder, we can manage our own folder structure. Status information. So the status of the computer system and status of the applications and many more will be provided as a service. File modifications can be done. So we can rename, we can delete, we can reduce content, right, like that. So then programming language support. So we can install many programming languages with their own compilers and run and do certain program development. Program loading and execution. So how the programs are loaded and how it is executed. So those are managed and the service will be available for the users. Communication. So how do we communicate to the different devices like a webcam or printer, or we have a scanner, right? So then application programs. So how to manage the application programs and how application programs are controlled inside the operating system. So you can see operating system is not just a single service. It provides many services, and for each of the services the operation is complex, especially when it comes to multiple services provided for a single user, and all these services are used by a user at any given time. So by using the system programs, a user can easily maintain and manage a computer system. So the services that are essential for the end user are listed here. For an example, like file management, we can create a file, delete, copy, rename, we can print. So all will be linked into a particular service that is provided by the operating system. So one service will provide certain operations, and from that service another service can be executed as well. For example, we can create a file, we can open a file, we can take a printout. So there will be many services involved in that particular set of operations or tasks. So system information, we can have date, time, the amount of memory, free disk space, like that, number of users connected, the bandwidth available, the last modified date of a file. So like that, there are many, right? So certain performance details, debugging information, the log, how many people are logged and when, and then about certain configuration information. So when we install a particular application software, what are the available resources and how it is configured. So those will be available as status information. So file modification, we can have different word processors, text editors, or some operating systems provide certain text editors in the command prompt also. So programming language support, we can install different programming language software, and also we can have the necessary compilers to it, and debuggers, interpreters if required, and then program loading and execution. So we will cover this in the next chapter, on chapter 3, on process management. So how the processes are loaded and how they get executed and how they communicate each other, right? So communication, so how the users communicate, how the processors communicate, and how the different devices of the operating system communicate. So all these are managed by the operating system. So that is available as certain system programs, we call it as utility programs. So when it comes to the program execution and different stages in program execution, so we can have a matrix like this: privileged and non-privileged mode for different levels of execution in an operating system. So when we consider the two modes, that is user mode and the kernel mode, so user mode we consider as non-privileged mode, kernel mode is considered as privileged mode. So a user can access the application at the user level in the user mode, but it does not allow the user to enter into the kernel mode. So how does a user execute its applications? Then a user will use the application to do the task, then the operating system will take care of the task that is required for the user to execute. For example, if you want to take a printout or save a file, what happens is user will click a button in the word processor. So that is the simple task that a user can process. But on the operating system, the application will use the API to access the proper system call or the relevant system call, but without the privileged mode, the operating system cannot allow that particular operation. So the mode will be changed to the kernel mode, then the necessary system calls will be executed, and then it can use the secondary storage to save the file, and after successful completion, then it will return back the privileged mode into the non-privileged mode of the user. So the user cannot enter into the kernel mode directly. That is the important thing that we need to understand here. So now we will discuss about different operating system designs and implementation. So we can start with the basic operating system where we have a single user and each single program execution in a given instance, and to multitasking and multi-programming operating systems. So it's important to design the operating system properly to give certain facilities for both parties, that is for the users as well as for the system. So users point of view, the operating system should be convenient, easy to learn, should be reliable, safe and secure, and also it should be fast. We have to give quick responses. So those are the parts of the user goals and system goals are different. So mainly the system goal should be focusing on maintenance as well as implementation, usage, reliability, and error handling. Because an operating system should be easily maintainable for a normal user without showing the complexity of the inside operations to the end user. So that is very important. So it should be an easy design as well as it should be easily maintained, and then it should be flexible because there will be many applications for a particular user that desires to use. So based on that, the applications and its maintenance should be easy as well, and also it should be reliable. So the outputs that it gives should be accurate. So to design an operating system, it should have a policy and also mechanism. So policy means what will be done, right? So what are the things to be considered in reliability or error handling or maintenance. Mechanism means how it is implemented inside the operating system. So both are required to design a good operating system. So operating systems varies based on the requirement. So most common operating systems we use are based on users' requirements. So users should be able to load the operating system quickly, install applications, run many applications parallelly, take correct outputs, and like that. So the policy should be based on the requirement. Then the policies will be implemented in mechanisms. So that is how an operating system is designed and implemented. So another category of operating systems are server operating systems. So the goals for the user and for the system is different in server operating systems. So users are not the normal users, those are professionals in that particular area, maintaining and managing servers. So they should be able to access quickly. Most of the time they can access using command prompt. Then they have to manage the server. Sometimes they have to stop, restart, upgrade. So those things should be handled quickly in an appropriate way. And for the system goals, system should be mainly looking after the scalability and the performance, the usability, security, and those type of features. So based on different requirements, the policies will change as well as the mechanisms. So MS-DOS is the simplest of operating systems, single tasking operating system. There's no division in modules, and there's no proper hierarchy of accessing user applications to the devices. So it has a particular structure, but you can see later on in the next slide, it can access from any level to any level above or below. So although it has a structure, it does not provide a proper mechanism to go through the hierarchy, and that is one of the main drawbacks in MS-DOS. So this is the layout of the MS-DOS. So application programs will access the resident system, and then MS-DOS have its own device drivers to access the hardware. but some of the application programs can access hardware directly. So that is a main drawback in terms of security for the devices, and maintenance of this type of a structure will be very complex. Why? Because it does not follow a proper hierarchical order to access different levels. So any level can access any level below or above without any privilege change. So this is a simple structure because this is a single tasking operating system. At any given time we can run only a single task. Memory management easy, management of devices can be easy, but doesn't have proper hierarchy to access different layers. So managing the task inside will be a problem, and then it creates a lot of security threats internally. So this particular operating system does not have a graphical user interface. It comes with a command line interface to execute the program. Then we have the layered approach, where the operating system manage its tasks into different layers. So at the bottom layer they have the hardware, and at the topmost layer they have the user interfaces. So the advantage is the hierarchy is maintained always. So whenever a user wants to access the hardware, it has to go through the the, the topmost layer to the bottommost layer with proper access permission. So then the complexities can be minimized, so the process can be arranged smoothly from one level to the other. So different services can be also managed in each layer, and managing the operating system and the maintenance will be easier. So Unix and Linux system follows this particular approach of layered architecture. So you can see we have the user interfaces at the top, then we have the system services, and at the bottom we have the hardware, and the communication goes through the hierarchy. So easily we can maintain the security by maintaining the different privilege levels. So we can protect the system well as we can manage the available services and the hardware as well as the applications separately. So this is the file structure and how it is organized in the Unix or Linux system. So Linux will have a single directory, a single file tree structure, right? Starting from the root, so we create the directory structure. So this is easier to maintain, right? We can manage the necessary directories and files in a single tree structure. So we will discuss about these different directories and their purpose later on when we do the practical. Right? So the advantages of the layered approach: the hierarchy is well defined, right? And the system can be highly secured because each level requires its own privilege level to access, and can manage its own system programs, services, and do all the necessary uh, tasks inside the operating system securely. So the disadvantage of the layered approach is if we want to change a particular utility program or service from one level to another level, then it creates a major problem, because since the layers are well structured and the communication is already in place, if we want to change a particular service from one level to another level, then it creates a lot of effort. So in certain aspects, maintenance sometimes can be difficult, but if the maintenance is a smaller change, then it's not a problem, but major changes, it will create certain complexities. So the other problem is, so this has to go through a single service layer. All the services are handled through the service layer. So whatever the task that is required certain hardware access or service has to go through the service layer. So sometimes it might create a bottleneck in program execution. So then the microkernel system introduced. So why this particular type of design is introduced? Because we can ease out the work that is available for the operating system. So the kernel space is minimized, so that is why it is called as microkernel. So most of the tasks are moved as user modules to the user level. Then managing the kernel is also easy, because the essential requirements of the operating system is available in the microkernel. All the others are given as user modules for the users. So benefits we can extend. If we need any modification to the microkernel, we can do that, and the security for the operating system can be very high, and it is very much reliable, because the task that is run through the kernel is very much limited. So the disadvantage again in this particular system design is the overhead on the kernel space, because everything finally comes to the kernel space to communicate to the hardware. So then it creates a overhead on the kernel space. So this is another example for a microkernel. The kernel is divided into two parts, BSD and mash. So in BSD, it has different tasks, and mash will have the command line interface and certain services provided by its own. So application can access the kernel environment, and the convenience is the maintenance of the kernel, and high security is another feature. So then there's another design, that is the modular design of operating systems. So this uses the object-oriented concepts. So each module is considered separately, and then all the modules are connected to the kernel. So management and maintenance of the modules are easier, because we can easily maintain the module separately, and each module will be connected to the user space, and it is available as a user service. So so this particular operating system has the advantage of managing uh, each of these modules separately and easily. So this is a more flexible design when it comes to the implementation, because each module is managed, maintained, and can be upgraded individually. So this particular approach, modular approach, is being used by Solaris. So because Solaris is Java based, so it can go for object oriented approach. So each of these services are maintained as separate modules, and all this will be connected to the kernel. So again, the problem of having a bottleneck when it comes to program execution is still there in this particular uh, design as well. So we cannot actually change and do a perfect design for operating systems. There will be advantages and disadvantages. So the important thing is we need to balance uh, the advantages and disadvantages to have more advantages and less disadvantages for different requirements.